Hello students, I'm Kanhaiya Thakur. I welcome you all in this particular video. So in this video, we're going to talk about the question based on pseudo force, right? Let us see what's the question. The question is this: a bob of mass m is suspended from the ceiling of a train moving with a constant acceleration a as shown in the figure. Find the angle theta in equilibrium position. That's the thing we need to find out, right? So basically this question is based on the concept of pseudo force, that is non-inertial frame of reference case. Okay, so here what is happening, this is the train which is moving with some acceleration a rightward. Okay, and this bob has displaced leftward, and that is making an angle theta with the vertical, right? See, if you try to understand one case, if this train is not moving with some acceleration, or if the train is moving, if it is moving with some constant speed or constant velocity, in that case what will happen? In that case, the bob will remain vertical. The bob is not going to make any angle with vertical, right? But in this particular case, this is given that the train is accelerating rightward. Therefore, the bob is making an angle theta, and we need to find out that angle theta. So let me tell you how to do it easily, right? So if you talk about this bob having mass m, right? If you draw the free body diagram of the bob with respect to a person who is sitting inside the lift only, inside this moving frame of reference, which is train here, right? So with respect to this person who is sitting inside this train, that guy will tell you that, okay, fine, this is the bob which is at rest with respect to me, right? That means forces on this bob has to be balanced with respect to a person who is sitting inside this train, right? So let us draw the free body diagram and let us balance the forces and see what is happening. So consider this bob having mass m, right? The very first force that the observer will tell you is the weight of this acting downward, that is mg, right? Now we have tension here, and tension is making an angle theta, so this angle is going to be theta, right? Now if you talk about this component of tension, it is going to be t cosine theta, and this component will be t sine theta, right? Now we know that since this is the non-inertial frame of reference, so we have to apply a force, that is pseudo force, just to make the laws of motion valid. Otherwise we can see here the tension is acting t sine theta rightward, but the block has displaced leftward, right? Or with respect to that person, this t sine theta is not balanced by some force, right? So here laws of motion is not valid, right? But just to make the laws of motion valid, we have to apply a force here, that is pseudo force. And let us see what is that. That is basically the product of mass on which we are applying the force times acceleration of frame of reference. And the pseudo force is acting in opposite direction to the acceleration of frame of reference. It is a fictitious force having no action reaction pair. That's the concept we know, right? Now this is the balanced condition with respect to a person who is sitting in the lift. Okay, so that guy will tell you, okay, t sine theta is basically ma, that's the first equation, and t cosine of theta is basically mg, that's equation 2. So when you divide 1 and 2, what you're going to get, this t and t cancelled out, m cancelled out, sine theta by cosine theta is tan theta. So tan theta is going to be a by g. So from here we can easily see the theta is tan inverse of a by g. So that is going to be the angle. This theta is a by g, right? This is basically we did with respect to a person who is sitting in the lift. But if suppose if you want to solve the question with respect to a person who is sitting on the ground, then how will you solve it? So if you talk about, let us say there's an observer sitting here. This is our observer 2. So with respect to observer 2, what is going to happen? That observer will tell you, okay, this is the tension and this angle is theta. This is t cosine theta. This is t sine theta. And this is mg. So this force will be shown by the person who is sitting on the ground also. But that person will tell you the entire train is moving rightward with some acceleration. Therefore, this bob which is hanging inside the train is also moving with the same acceleration rightward, right? So with respect to that guy, this bob is having acceleration rightward a. Okay, so with respect to that guy, how we are going to balance it? That guy will tell you in the horizontal direction, he will tell you that t sine theta is this. So t sine theta is basically ma, mass times acceleration, and t cosine theta is going to be mg. Equation 1, equation 2. So you can see here we have the same equation. Again, when you divide this one, t and t get cancelled out, m get cancelled out, and we are getting the same case again. So here also this tan theta is going to be a over g. That means this theta is tan inverse of a by g. So that's the answer, right? So the theta subtended by this bob, in both the case we got, that is a tan inverse of a by g. Theta is tan inverse of a by g. So we have seen this question with two methods and we got the same answer. I hope this is clear to you. Thank you.